Hey guys, thank you so much for joining this session. Here is what we are going to discuss. Let me share my screen real quick. So this is part of the microservices series, which is currently planned as of now. It is planned for 120 episodes. Let me give you a couple of resources so that it will be easy for you guys to uh, track it. So one thing is this, my GitHub link. Put this in the chart. Okay. And one more thing I will give you is created a separate organization. So in this organization, we'll be using all these things, all the projects and repositories, everything will be created here. And this is, if you need to know more, you can go into this repository, but we'll come to this Learn C#. And here we are doing the second session. So the documentation will be here under S2. So I'll keep it as it is. And before that, this is the meetup group. And you can see that I'll be conducting different events, microservices, AWS, and Azure OpenAI, and easy certification series, different things. And .NET Learners House, that's the YouTube channel for the meetup group. So please subscribe to this. And also if you want to join, you can join this and subscribe to this. Whenever I upload a video, you'll get notified. All the videos are here. And this event is being conducted as part of the Microsoft Learn. Okay, so you can see, you can find me here in the techcommunity.microsoft.com under this Learn Experts for Azure. You can see me. And another thing which I wanted to mention is each of those Learn Experts have been given a learning room. Like you can see this is my learning room, Swami the Learner. So I'll be conducting events from this learning room, but I'll publish it from my meetup group as well as here. Okay, so that's the brief introduction. So let's go ahead and start discussing today's topics, what we are going to discuss. So this is 2 of 120, long journey, long way to go. I'm going to give the meetup link and the traditional slide, which I always show in every session. Please fasten your seatbelt. We have a lot of things to discuss. So these topics are there. So I'll quickly set up the context. What is that we are going to do? So in the previous session, we have created 2 CS proj, and we saw the program structure with main and top level program structures, and we discussed some of the fundamentals. And now what we will do is we'll create an empty folder, and then we'll create the solution and copy the 2 folders from the previous session here, and include that in the solution file. And then we'll create a new console application and a class library of VB.NET. And then we'll modify the VB.NET with the same math class which we had it in C# and use it in the console application. Then we'll execute all these 3 projects. And then we'll create another library which is in C#, the same math service, and use it. So then we'll stop and we'll think, how is that we are able to interrupt? That means we created a library in C#, we created a library in VB.NET, but we have used those 2 libraries in console C# application. How is that C# application understands VB.NET language? We understand that C# library versus C# console, it can understand, but how is this? What is the underlying infrastructure which is making this possible? We'll give a 30,000 foot view. In the next session, we'll dig deep, we'll do a deep dive into that and find out what is that which is really making this possible. Okay, without further delay, let me hit the road. So as I was mentioning, all these sessions will be live sessions. So zero sliders live sessions. So let's start doing step by step. So I just created a empty folder. Let me come in here and cd into this one. I'm already here. So the first thing is step by step. We will go ahead. What is the first command? The first command is we will go ahead and create a new solution. Again, .NET list SDKs. You can see that version 8, preview 7. Okay. Next will be RC1 release candidate. So we are creating this one. So what I will do is I will open the code here. That will help us visualize what is that which is happening. At this point of time, we can see that it has created a solution file. Okay, so just 10 seconds gap. I'll have a glass of water. Okay, so I'm here. That's the first command we executed. Then what we will do is copy two existing projects from S1 folder into S2 folder and add them to the solution. So in the previous episode, we have created those two projects. Let me copy those two projects here. Version 1 and version 2, I'll put it here. Cool. So that was a step 2. So let's quickly go, and we'll not spend much time into that because we already seen it. It's there's a traditional mustaches or main class code program structure, and this is the top level program structure, and we discussed that top level program structure is available only in the program.cs, only once in this project. And you can see that math service is common in both. We will start reusing the reusable components and libraries in future, but as of today, this was the one which we discussed in the previous session. And also we saw that how is the main class getting created. The compiler creates the program. Here you don't have the main method, but the main method is the one entry point to every program that we discussed. So the main method is being created by the compiler. That also we have seen in the previous session. So now we will go ahead and add these two projects. So the only thing is I changed the change this color of this one, and you can see that the project has been added. And we've added two projects. If we come and check this solution here, you can see these two projects has been added. So we are done with the step 1 for today. We completed, and both the projects has been added here. We just added this one. Just wanted to ensure that we did not create anything wrong. So we'll do .NET Restore quickly. So it's determining the projects it was able to determine, and we'll do .NET build. Let's give it a minute to build this project. It was successfully built the project. Then we'll do .NET run the project. Let's execute the first project. We executed the first project, and let's execute the second project. Second one was the top level statement. First one was the traditional one. So we executed this project, ensured that we created a new folder for session 2 and solution file with S2, and copied these two projects from the previous folder to this new folder and included those to the solution, and we restored, we built, and we were able to execute, ensured that all is well till now. Now we'll go to the step 2 of the process. So in this step 2, what we will do is we'll create a third flavor of the program structure, and we'll create a VB.NET class library. Okay. You can connect all these dots in the next session where we will do deep dive into the process of few other things and process and the infrastructure which is helping us to do everything we'll see in the next session, but at least to a decent extent we will cover in today's session. So the next thing is we will be creating another project, the program structure 3, and we'll include that into the solution. Cool, we did that. And then we are going to create a library. Let's see real quick how is that it looks. Now you can see that we have 3 projects, 3 console apps, the solution, and solution has included all these 3. Now let's come back to this. Now this time .NET new class lib. Output is MathServicesVBLib, and language specifically I'm telling that I want VB.NET. So let's go back to this console and execute this command. And you can come back and see that it has created a VB.NET class library. And you can come in here. You can see this. It has added the namespace. And all the projects which we are working, those are .NET 8. So this is an executable. This is a class library. So 3 C# console application and 1 class library. That's what we have as of now. And let us add this VB.NET project class library to the solution. I just included. Now let's come back and look at this solution file. So you can see this 3 console apps as well as the VB.NET library. Everything has been added here. So after adding that, we can do one thing is we can stop for a minute to find out whether are we able to execute all these projects. Is there anything wrong? Okay, that we need to find out. So first thing what we will be doing is .NET clean. So we just added these 2 projects. So right now, if we go and check, the solution has got 4 projects included, 3 console apps and 1 VB.NET library. So we just want to ensure that all is well till now. So that's what we are doing in this step, executing all these 3 console apps. So we did a clean, and then we do .NET restore and .NET build. So it has built all these things, 3 console apps as well as the library. So let's step into this just to ensure that instead of just saying hello world, hello from, let's give the project name just to identify that. I mean, there's the only line which is coming in. Other 2 projects, console apps have some content in that. So no need to worry on this. Let me come back here. We did the .NET restore and .NET restore done. .NET build, that's also done. So let's again go back and ensure that we're able to execute all the projects. So the first one is demo 1. executing the demo1 project. And now I will execute the demo2 project. And this time, let's execute the demo3. There's nothing in demo3, but we will execute it. It just displays a message, hello from program structure 3 void. That's it. So with this, we are sure that whatever the new projects which we have created, one VB.NET library and one C# console app, everything is working as of now. Okay, that does not mean that it is going to fail in future, but as of now, it's working. So another thing is modify the VB.NET library, okay, and add it to the program. So let's come back to this one where we have this. I'll rename this file the class library. Let's come back to this one, and then these 3 lines. It's the same functionality, whatever we had in C# library. You can see that I'll place those C# library and this one side by side. Then we can see so the namespace is different. Math class. Here static max value. We call it as share in VB.NET, and we have an instance method add numbers, and add numbers v1 is again a static method. There's nothing new. It's a same functionality at 2 different places. Right. So we just added that step we have covered. I'll close this. So we just added, and now we need to add this library over here. I think I already added that ahead of the game. Oh, no, I didn't add it. It is here. We added to the solution. We need to add to the project. So we can do that in 2 ways. One of the ways we can copy this line and paste it. That is one way we can do that, or we can add the library using the command line. Let's use the command line. So I will place this over here so that we'll see how is that it's adding this line, the same line. When I enter, you see that the same line has been added. So we can either, if you know that you're sure that we will be adding this project from here, you can either directly go and add it or through the command line. I mean, whatever works best for you. So we just added that project. Okay, that's what I just demonstrated this. So after adding that, what we will be doing is we will be modifying the program structure. I mean, the program structure demo3 and execute the project. Okay, so what we will do is we'll come back to this one and copy this program structure. We'll copy the entire code, but we'll modify step by step. Okay, so this is not it in. I'll remove that, and I'll remove this piece of the code. Then we'll come back and we'll learn that. So if you see that this program structure demo v3, we have included the VB.NET library into this C# project. And now we are modifying the program structure. So how do we do? Let me show you that. First thing is we will go ahead and execute this without adding this using statement. So let's come and execute this program structure demo3. The demo3, it says that it's unable to find the math class in line number 17, comma 1. Line number 17 is this one. It's over here, math. And all the places wherever we are using the classes or methods from the particular from that particular library, everything it's not able to find. So one of the way what we can do is we have to enable or start using this library. So in VB.NET, if you come here and go to the bin and you see this, this is the library. Okay, MathServicesVBLib, that's the library. And inside this library, we will be having the inside that library we will be having the code for that. So let me quickly go here and check what is the difference between both. Both are same. So if I'm adding in here, let's see this for a minute, and you can see that. So this math class over here exists within the within this MathServicesVBLib dot math library. So that is the namespace it is coming in from. So this is the module it is declaring. But to understand, we are getting deep into the weeds. So to access this particular class, math class from this VBLib, how do you need to add the namespace? It exists inside the MathServicesVBLib. What is this MathServicesVBLib? That is the library. See this MathServicesVBLib. So that's the library dot the namespace. If you come in here, you see this MathServicesVBLib dot DLL. That is the library. And inside that library, the namespace is math library. So how do you access this? The namespace of the DLL, sorry, the name of the DLL dot the namespace within which the class exists. Again, I'll repeat. The DLL name, MathServicesVBLib, that is what we are seeing here, MathServicesVBLib, and the math class exists within the namespace. So this is the full namespace we need to add to access it. So we'll see that. We'll come back and we'll use this. So you see that I'm saying MathServicesVBLib. So the MathServicesVBLib. So that is the library name. And math library. Where is this math library coming from? The math library is declared inside the MathsVB class. So within that class, the class has been declared within this library. So we declared that way. So the DLL name dot the namespace. Within the namespace, we can have multiple classes or whatever it is. We'll create it. So just wanted to go deep into the weeds to find out how do we know what should I add to have a compatibility between the C# and VB.NET. This is the way. Okay, now we understood. So these all code are from the previous one. So let's focus here. So we created two variables, num1 and num2. And now if you see this, the math, it is going in and accessing the VB.NET library. And we didn't even discuss about the debugging and how to execute the program using the Visual Studio Code. Please hold on till the next session. Next session, I'll teach you how to do it. Okay. So now we are building a lot of fundamentals and seeing under the hoods what is happening. So that is more important. So let's see that first. Okay. So what are we doing here? We created the math object and we are invoking the instance method. And now we are accessing the static method. We are using the same num1 and num2 and invoking the add numbers v1, which is a static method. And another thing is we are also accessing the math.value. Okay. Now what we are doing is we are using the math.maxValue. That means this one. We are using this integer type, which was declared max.mathValue, and we are assigning it to a int of C# type. So the variable, the max value inside the VB.NET has been declared as integer, but when it comes and we are assigning that to C# variable. Okay, and how is this all working? Let's see that in the execution now. Let's come back and then we will go to the theory afterwards. So we executed. Now see this, one thing to observe is when we did a get type, on maths.maxValue.get type, it says that it is system.int32. Okay, and again, when I did the same on C# variable, this is coming in from the VB.NET library, and this max value, this is the C# variable. When I did the C# variable, even that is pointing to the system.int32. So there is a common type which has been declared. All the languages should adhere to this common type. So that is what it is making possible, even though you create a library in different language than C#, but you are able to happily use it. And also intermediate language and other things, which we will do a deep dive, like how we went into the IL-SPY and saw that. Similar things we'll be doing in the next session, which will be a little bit more advanced than what we are discussing in today's session. Okay, so that is the first example, interop. So we came back to this one and let's continue over here. We executed and we saw this very critical piece. Now what we will do is we'll create a C# library. Now we'll create another library which is in C#. Let me create this C# library. This is everything we are doing through the command line, CLI and VS Code. That means we are doing everything so that we'll be able to work in any operating system. All the open source tools. Okay, you're increasing your horizon. You can work in Windows or Mac OS or Linux or anywhere which gives you a console, and .NET 8 is there, VS Code is there. You'll be happily able to work. Other tools are also there, JIT and a lot of other tools are there. IDE is a very good one, but I'm speaking about the VS Code because I like it. That does not mean that I don't like other IDEs. I use all those JIT and other things which is in my another virtual machine. This is very specific. I'm discussing in this series, focusing on Visual Studio Code at this point of time. I might bring in new tools going forward. That being said, let's create this C# library now. So this is What is that? Creating the template. Why? Oh, I already created it. I'm sorry. I already created it. Let me come and see that. Yes, the C# library is already there here. So I'll close this. So the C# library is already there. So one thing I just want to highlight it again. If you see this .NET new list, we tested this command multiple times in the first episode, the first session. And by default, if you see that, it will give you the supported languages also. And by default, for all these templates, C# is the default language, which is marked in this square brackets. And the command which we used when we wanted to create the VB.NET library, where we explicitly specified the language to be VB. Here, hyphen language, we explicitly specified use VB. So if you want to create F#, you can specify hyphen language F#. By default, it is C#. So in the VB.NET library, we explicitly specified that it is VB. Now here we didn't specify anything. We just executed a command that itself created a C# library. Now let's come back here to check. We only have 4. So here we are seeing 5 projects. Okay, 2 libraries, 3 console apps, but here we see 3 console apps and 1 library 5. Right. So let's go back and execute this command to add the C# library to the project, the solution file, technically. I am executing the command, and now if I come and see that, so 3 console applications, 2 libraries, all 5 files has been added into this. So the next thing, traditionally what we will do is we'll come back and do .NET Beam, just to ensure that adding something new, we didn't break the existing one. Then we do .NET Store, .NET Build. So you see that because this console application has got the dependency on these 2 libraries, that is the reason the order in which it is building is it understood that this library, to execute this library, we need to have to execute this console application, we need to have these libraries up and running. So it compiled these 2 things before compiling the console application. That is one key point which we need to understand. So let's come and execute all these projects because we didn't change anything there. I am executing the project tree. Technically, we can execute all these 3 projects. There's no harm in doing it. I'm a little lazy, so I stopped it. Now, what we will do is we will go ahead and copy this because technically it is nothing new. Whatever is there, only thing is to differentiate because we'll be using this class, the C# library, as well as the VB.NET library. If I have the same class name, again, I have to prefix with the namespace just to avoid all those things. I just because technically both these math class exist in 2 different namespaces. I can specify the namespace.class, namespace.class. It's a little bit longer, but I thought let me use a new class name so that I can directly use it at the top using statement and start using this one. So this is the library which we are using it. Okay, and then that library, we are including it in this project, the CS proj. So let's come back to this one and use the CS proj, and let's do the same exercise what we did previously. I'm pasting it here. You will see the line number 3, 4, 5. I execute this and execute. It added the C# libraries reference. Previously, the VB.NET libraries reference was already existing. Now we just added the C# libraries reference. So that's cool. And let's go and execute this. Ensure that we didn't break anything. Just to be on the safer side. So that we didn't break anything, but cross-checking for another time. So we saw that and we executed it and we didn't find any issue. So now what we will be doing is we will go and start using the C# library also. So here is the one where we started using the VB.NET library. So let me bring the code where we'll be using the C# library. So the dark cyan, I will get this. And whatever we are doing in the VB.NET, the same thing we are doing in C# also. You can see that to differentiate, I'm using 2 different colors. So here we created the variables we have created once. We created the instance of the math class. Here we renamed it as MathCS. We did that instantiation. And then we are calling the instance method, line number 18. The same thing we are doing in line number 31. We are calling the instance method here. And we are accessing the static members, the same thing. Here we are calling the math class dot add numbers. Here maths CS, that's the C#, just to differentiate. We said that add numbers V1. So we are accessing, and then we are accessing the max value property. That's again static. Here it's called as shared. Then the next thing what we are doing is we are accessing the type. This is the VB.NET max value get type. This is math C# library math value.get type. And again, the C# library dot max value we are assigning to the integer variable which has been declared within the C# console application. Here VB.NET max value, which is declared as a type integer, its value we are assigning it to this. And the next thing is we are getting the type of this. Okay. So now let me execute this project. .NET. Let me do a clean. .NET restore, get all the libraries dependent. .NET build the solution. So it builds the libraries. So here you see this, it's not able to find it. The MathCS. So we need to go back to this and see it is available inside the MathServicesCS library. That's one difference, and we are using it. The using statements between the VB.NET library and the CS library. Now again, come and compile this. So you're seeing that everything has been compiled. So in the VB.NET, what we are doing is the DLL name dot namespace, including the reference is same for both, but how do you use it? One of the ways is the DLL name dot namespace. Here it is directly the namespace. Now all is well. So let's come and execute this. .NET run. Structure. We're executing the see that. One thing to focus here is system.int32. Even though this is a static member which is coming in from the VB.NET library. And the local variable which is declared in C#, even that is saying that its data type is system.int32. Now, if you see that the C# library, when you're using the max value, it says that it is of system.int32. And the local variable also specifying the same thing. So this actually I have to copy this. It's not math. It's MathServices. I should be a little careful. This one word. Okay. So now we were able to do this. Let me go back to the documentation. And here I placed one image where you can see the math library in C#, math library in VB.NET, and the console application. Now we will understand few of these things in a little bit deeper. I mean, this is like a 30,000 foot view, but we will definitely come back to it in the next session where we will dig deeper. So the common type system. So you can see this one. This is like implementation. .NET implementation is language agnostic. So in order to use it, as we know that whatever the language, .NET compliant language you create, all these things has to adhere to the few of the rules of the game. So one of those is the common type system. Okay, maybe those are the primitive types, or the whether those are the primitive types or those are the user-defined types. But all the rules of the game is same. So if you see this here in this types in .NET, there is another link which I have taken, but let's wait here for one more minute. And another thing is common language specification to enable full interoperability scenarios. All the objects that are created in code must rely on some commonality in languages that are consuming. Okay, so this one, if you see that different languages are there. So common language specification. So common language specification is subset of common type system, because the rules are same. Like any language which has to be the .NET compliant has to adhere to the rules of the game. That's one important point. Let's go and let's see this one: language independence and language dependent component. CLS compliance rules. There are some of those things. It is there. Just you can go through this this documentation. Like we can also use the direct common or the base type, even though if it is a C# programming, I could have very well declared this as an int, but you can use the common compliant one, which is like unsigned int or long or these things which are there. We will see that in a minute, what those things are. if you come and see the common type system, I think I pasted that link twice. And this is the one which is very important. Okay, see this is one of the base type. So instancing and int32. So the common type is int32. When it comes to C#, we are calling it as int. When it comes to VB.NET, those guys will call it as the integer. So F# might call something else, but overall, all are pointing to the same type which has been declared. And there is one other thing which I wanted to show you. Here, see this. Here, see the common type system, and the virtual execution engine. Will come back to that in the next session, where we'll dig deeper and see things. Here at this point of time, what is happening is whether you write code in any of the .NET compliant languages, the Roslyn compiler, in our case, C#, or the respective compiler for that particular language, that compiles everything into the common intermediate language. MSIL, SIL, or IL, whatever the names, common intermediate language. Previously, MSIL, now they're calling it as IL, different terms, but pointing to the intermediate language. Okay, then the common language runtime will take this and do a just-in-time compilation and convert that into machine language. This we have seen this, we are seeing it for the second time. Next session, we'll see this, but again, dig deep and get into the files and see how is this and do a one-on-one mapping. Like we went into the ILSpy and saw the code. Similarly, we'll use some other tools. We'll get into that and we will see how these debugging and the compilation and other things are happening. We'll see that. So now we at least understood from a 30,000 view perspective what common type system is, but I am there is a nice table which clearly gives you that. That's what I'm seeing, that table. I think in 32. Where is that? No, it's not this. See this, when we declare int data type in C# and VB.NET, they are converted to int32. But there is a table. I think I copied the wrong link and pasted it twice. Let's see, is it here in this link? It's buried somewhere. Types in .NET. Professors, delegates. Wait a minute, guys. Sorry. I thought I have copied it, the link, but oh, okay, here, I'm sorry. That's what I was looking at. Now, when you convert that, see this, the common type system is int32. When we are using that int32, in C#, it is known as int. And when it comes to the VB.NET, it becomes, I mean, from the VB.NET perspective, it is integer. From the C# perspective, it is int, but they both point to the int32. So see this, for F#, what is that these guys are calling? Okay, they're calling it like this. And let's see what is that in C++. C++ is also int. So the common type system and the common language specification, these are some of the rules of the game, which makes this interoperability very much possible. So we will do, this is like we saw things at the 30,000 foot level view. But in the next session, what is that we are going to do is we'll deep dive, go into the weeds to find out what is that intermediate language looks like for a VB.NET library and for the C# library. We'll compare, we'll dig one level deeper. In that image, if you see that, we will dig deeper into this language. We'll use another tool to go and see that how is that both are being shown. I think I have captured that image. I don't remember correctly, but if I'm not wrong, if I have captured it, I can show you the image. Where did I capture that? I don't remember where did I capture that. Okay, I didn't capture that. I'll be doing this week. So the next thing is we will use debugging tools to find out about the JIT compilation. Like what is this JIT compilation, how it happens, and then we'll move a little bit faster. There'll be a lot of topics which we are going to cover in the next session. Okay, so that's it from my side for this session. Thank you so much. See you guys in the next session.